Hello and welcome to a quick video tutorial on how to create a component in Flowcode version 6. I'm going to create a new project and I'm going to select a device. The device doesn't really matter when you're creating a component, as the user will be able to select their own device, but I'm going to select just standard 16F877A. Once Flowcode is loaded, you can see this is the layout of my interface. So you see I've just got the Project Explorer on the left, I've got the panel properties on the right, I've got the dashboard panel and the system panel. For this program I'm only going to need the system panel, so I'm going to get rid of the dashboard panel just to give me a bit more room to work with. Now the component interface comprises of a few menus on this right hand side properties panel. We've got Settings Manager, Interface Manager, Resource Manager. We've got videos that detail what these managers do, but I'm just going to run you through creating a component and then how to use these managers to finish the job. So a component can be anything really. It can be a set of routines which include other components. So for example, if you have a component that you use all the time in a specific way, then you can write code around that and you can store it into your own custom component, which will allow you to just bring that component into your program whenever you need it, rather than having to rewrite code or export macros or do things like that. It's just a clean way of wrapping a set of code up into a single item that can be dragged on. So what I'm going to do is I'm going to add a stepper motor to my program. So in the mechatronics menu, we've got stepper motor base. This is basically the code to drive a stepper motor without any simulation. And the stepper generic is a generic type stepper motor. So it's the same code underneath. It's just got a front end which allows you to do things like move objects on the panel. So I'm going to just drag this into my system panel, and you can see I've got it selected. I can drag it around, place it where I want. If I hold Control and I've got the rotate item selected, then I can move around like this. By clicking on these arrows here, I can snap to a view. And if I select the item, then the properties for the component appear here. So you can see I've got some connections for the coils, I've got the type of motor, I've got simulation properties which allow me to show or hide the coils and the arrow. Stick the arrow back on for now. We've got a link to, which basically allows you to link the drive of the motor, the drive shaft, to another panel object, which allows you to build things like robot arms or anything like that. And you've got this gear ratio, which is how much the connected object will rotate per given step, or you've got this linear pitch, which allows you to move an object linearly rather than rotating it. So this is for the example where you've got something like a threaded bar connected to your stepper motor and you want something to move forward and backwards, like on a 3D printer or a XY plotter. So here we've got the motor. If I click off the motor, then you can see that the properties list disappears and we have nothing here anymore. When you're creating a component, the properties here, so with panel selected as the root item, we can add in our own properties which will appear. For example, when you click the motor, it'll be when you click our new component, the properties will appear then. So we can right click this and we can say add new. And what we want to do is we want to provide an easy way of referring to our code, but make it as flexible as possible so we don't have to keep going in and making changes, and it makes it useful for lots of different situations. So the properties I'm going to add are just going to allow me to change which pins the stepper motor is connected to. So I'm going to select a single digital pin. I'm going to call this motor 0. Should add pin as well. Motor pin 0. I'm going to add a variable. The variable can't have spaces. It's just like a normal variable, but it's I suppose it's more like a constant here, because the value, once simulation running or once the code is compiled, cannot be changed. So I'm going to call this motor pin 0. It's visible and it's writable. Click OK, and voila, we get our motor pin. Now what we can do is we can set an event. So I'll click on the events in the Project Explorer. Whoops, reconnect that. And I want a component property event. So whenever this property changes, I basically want to take this property and I want to pass it so that it replaces the value here. So it basically allows us to set the value of this stepper motor from outside the stepper motor component itself. So I double click the property event, and currently it's set to disabled. I'm going to click macro. This creates me a new macro called EV property, and just clicking OK allows me to define a macro that will be called whenever the property event is triggered. So whenever this value changes, this macro will be called, and I can see this macro by clicking on the macros tab, double clicking EV property, and here we have the macro that will be called. So what I'm going to do is use the simulation icon, and in the functions menu I'm going to go into component, property, get value. The handle is this because this is the current root of our component source, and when we've exported this as a component, it will still refer to itself rather than referring to sort of the main root of the project. I'm going to say the property that we want is motor pin 0. Now it's asking for a string, so what we have to do is just pop speech quotation marks around this, and then the field turns white to clarify that the data is correct. And then each property is stored as a string, so we need a string variable to store this into. So we're going to go to locals, and we're going to create a new string variable to hold this. So we're just going to call this temp string. Okay, double click the variable and it's popped it in for me. Now we want to pass that to the connections on the stepper motor. So if I click on the stepper motor and then I click on the coil 1 property, you can see that the property has a variable name called coil_1. So what I need to do is create another simulation macro. Functions, component, property, set value. And this time the handle is not this, it is from the components menu, it's the stepper motor. The property string is coil_1. You can still see it down here, so that's quite useful. And the value is our .temp string local string variable that we created. So if I save that now, it'll ask me where I want to save that. So I'm going to stick it on my desktop for now and call it motor component. And you can see that if I take this motor pin 0 and connect it to a pin, RB7, it's connected coil 1 to RB7. Just to prove I'm not lying, RB4 is connected to RB4. So what I can do now is I can go duplicate via the right click menu, it's motor pin 1, so here we have all 4 pins set up, and now when I set the value here, so RB5, it should copy all the pins across to the motor component. We don't really want to expose much else just for this basic simulation, so I'm just going to leave it at that for now. What I'm going to add is a switch, and this switch will rotate the motor in a particular direction while the switch is pressed. So I'm going to create a macro, which I can call via my Project Explorer. So macro add new. This macro will be read switch. And what we're going to do is we're going to check if the switch is pressed. So we're going to call the switch component and the read state macro. I'm going to save that into a local variable. So it'll be switch state. Okay, and double click to add it. And we're going to have a decision, which is if switch state. So if the switch is pressed, then we're going to enable the motor and we're going to step the motor. If the switch isn't pressed, then we'll disable the motor, and this just allows the motor to not overheat while it's not moving. And in our main, now the main can be seen as a test routine for your components. So what you can do is you can add code here that calls the macros that you're going to use as your component and allows you to test that the functionality is going to work before you export, which means that you don't have to keep exporting, check it works, and then go back and export it again to fix bugs. So I'm going to have a while one loop, and I'm going to have a call to the read switch macro we just created, and then I might just add in a little delay, just so we're not hammering this event, and just so the motor doesn't go off on one when we start spinning it. I'm going to save that, and then clicking play. The motor's still until I press the switch, and then you can see it starts to spin. Now what we haven't done is added a property to allow the switch to be configurable, so I'll add that now. So there we have the code to pass the property from our component into the switch. So I can connect that to A0, and then if I select the switch itself, connection has been rerouted to switch A0. Next, what we want to do is decide what we're going to make available to anyone who's going to use our component. So here I really only have one macro which is useful, and which people would want to use in their program, and that's the read switch macro. So in the interface manager, click and that brings up this window. We can choose macros and constants to expose to the user's program. So I've got this macro, and I'm going to change it from the read switch macro. I'm going to change it from hidden to downloadable. And downloadable means it will simulate and it will download to an embedded target and function on the embedded target. You can see that under the type of macro drop down, there's a simulation macro. This basically allows us to override the simulation side of things. So if you've got a bit of code that works on the embedded target and you want the simulation to do something else, this is how you would then split off the embedded side stuff from the simulation side stuff. So for things like comms, when we use consoles and injectors, the embedded side stuff will talk through the CAL, which is the chip abstraction. The simulation stuff will actually talk through the injector. So that's just an example of where the data splits off between downloadable and simulation. So it's a downloadable macro, and that's basically it. We've now exposed this macro as part of our component. So that's pretty much it. So I'm going to save this again, and I'm going to go into the settings manager. The settings manager does a few things for you. So it gives you a name. This is the sort of variable name, if you will, of the component, which will be used in the properties. When someone drags the component onto the panel, it'll go here. So we want some kind of a meaningful name. So this is going to be stepper motor switch. cosmetic name is what appears in the component drop-down, so we can say stepper motor with switch. And we can put it in the mechatronics category. We can choose category we want, we can choose what version numbers. For the image, you can choose an image of the panel, or you can untick that and it'll add a default icon, or you can override the icon here and select an image. You can enter a description, so here is a short description. Under advanced, you've got auto center, so this basically means that the objects will be auto-centered before they're exported, so that when you drag it on, the component will be centered around the mouse. The unit scale is whether or not it will shrink the component down to be 1 by 1 by 1. In most cases, you probably want that to be on. Supplementary header code includes any code that you might have popped in from the project options supplementary code. This was as was in V5. Dynamically load basically says whenever you reference this component, use a version of the component from the components repository, or use a version that's packaged into your own component. If you dynamically load, then if you fix a bug, then any component that refers to your component, that bug will be fixed. If it's not dynamic, then bugs will remain, which may or may not be a good thing. And inherit macros from a subcomponent, that basically allows you to control here where you have a base and a few sub-items on that base. It basically allows you to bring through the macros from the base component, and as well as either overriding or adding new macros. So to finish the export process, it's file and export component. These just allow you to confirm that all your settings are as you expected. Under advanced, something I didn't cover was the GUID. If you click edit, you can generate a new one. If there's already a GUID for a valid component, the name will appear here, so just be careful when creating new components that you don't overwrite existing components by overwriting their GUID. Always make sure that this is clear if you're making a new component. Click OK, ask me to save the changes, and then it'll ask me to generate an FCPX file, which it says has exported OK. I can now take that file and either drag it into my components library in V6, so that's in the V6 directory, then components, or I can say via the global options menu, the locations that my components are stored in. So here you can see I have a few different directories, each ended with a semicolon, that allows me to store components in my own custom directories, and then if anyone else wants to use Flowcode, they can just change the directory and use their own components, and the two components won't conflict with each other. So if I now create a new file, so a new project, choose 877A again, and there we go, stepper motor with switch. So I can drag it on, and I can see the various pins, the switch pin, and it should just be a case of creating a loop, component macro. You can see this is the component, this is the function that we exposed. Click OK. All I have to do is click play, and we've got that functionality there, and we can add this into any project that we want. If you want to be able to explore the properties within a component, then this can be a very useful feature when designing components, which is the component debugger. Component debugger will allow you to do things like monitor events, so you can see when they're firing, and the events are things like the property change. So if I click that to monitor and then change a pin, you can see there's a few graphics redraw events, and right at the top there's a component property change event. Another useful feature is the expose full tree in property pane. If I tick that, then it allows me to, up here, I can select And it doesn't just show me the component, it shows me all the bits that go in to make up that component. So I can select the stepper motor, and then I have direct access to these pins should I wish to change them and override the master setting. This is useful if you don't want to have to expose all the properties, but obviously it makes it harder for anyone else that's going to try and use your component off the bat. I think that's about it for creating a simple component, so many thanks for watching, and I hope you enjoy version 6.